Welcome to the Genius Factory. Enjoy the video.
You start by assembling targeted data and the right tools. Gather a balanced set of images and label a small core set first so you can iterate fast. Install Python, a GPU-enabled ML stack, and an OCR library or model scaffold. Once done, split data into train/val/test sets and create a simple preprocessing pipeline to crop, deskew, and normalize. Make sure to keep raw originals for later augmentation and debugging. Now focus on labels and the training loop. You should create consistent bounding boxes and exact transcriptions so the model learns both detection and recognition. Once labeled, run augmentation to increase robustness and then fine-tune a pre-trained backbone rather than training from scratch. Track character error rate and validation loss, adjust learning rate, batch size, and augmentation intensity iteratively. Make sure to use callbacks for early stopping and checkpointing so you can resume from the best model when experiments diverge. Finish by converting your best checkpoint to an optimized runtime format and testing latency on target hardware. You'll export to ONGs or TF-Lite, apply pruning or quantization, then validate outputs on a held-out set to ensure no accuracy drop. Once deployed, create simple monitoring that captures confidence scores and misreads. If things go wrong, check data mismatch first. Most failures stem from unmatched preprocessing or unseen fonts. Collect those examples, relabel, and retrain with targeted augmentation.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.